Hi everyone, this is A.THASNI from Department of Computer Science and Designing from SNS College of Engineering. So now we are going to see about the distance measures and attributes for each and every object. So how distance measures is implemented in for the attributes. So distance measures for objects with quantitative attributes. How when dealing with the objects that have quantitative attributes, that is attributes that are numeric, several distance measures can be used to assess similarity or dissimilarity. The choice of distance measure depends on the nature of data and the specific application. Here is a detailed overview of a common distance measure used for quantitative attributes. Euclidean distance. Definition: the straight line distance between 2 points in an n-dimensional space. Where the application be widely used within the clustering algorithm like k-means, k-nearest neighbors, and the various machine learning models. The main characteristics are sensitive to the scale of features, suitable for continuous data, and when the data is normally distributed. Manhattan distance. The definition is measures the distance between 2 points along axes at the right angles. The application mainly used in clustering algorithm, optimization problems, and scenarios where movement is restricted to grid-like paths. Less sensitive to outliers compared to Euclidean distance, useful when dealing with the high-dimensional data. Next is Minkowski distance, a generalization of Euclidean and Manhattan distance, where p is a parameter or p equal to 1 becomes a Manhattan distance, and for p equal to 2 is the becomes the Euclidean distance. So the application mainly used here is flexible distance measure used in clustering, classification, and other machine learning tasks. The main characteristics are the choice of PFX, the sensitive and interpretation of the distance measures, allows for flexibility in capturing various of differences between data points. Next is Jaccard index. The Jaccard distance measures the distance similarity of two dataset items as the intersection of those items divided by the union of the data items. So J of A of B equal to A intersection B divided by A union B is equal to A intersection B divided by A plus B minus A intersection B. So the Jaccard coefficient is A intersection B divided by A union B. Next is cosine index. Cosine distance measures for clustering determines the cosine of the angle between two vectors given by the following formula. Sine of A of B is equal to cos theta equal to A minus B into A or B. Here, theta gives the angle between two vectors and the A and B are n-dimensional vectors. Now, distance measures for non-conventional attribute. When dealing with the non-conventional attributes such as categorical, ordinal, binary, textual, or mixed data types, traditional distance measure used for quantitative data may not be appropriate. Instead, specialized distance measure are used to handle these type of data effectively. Categorical attributes. Categorical attributes represent distinct category without any inherent order. Having distance measure the number of positions at which the corresponding elements are different. D of p comma q is equal to sigma of n number of I equal to 1. P of I is not equal to q of I. Application is suitable for comparing strings of equal length or categorical data where the comparison is straightforward. The main characteristics is simple and it is effective for binary and categorical data. So the matching coefficient is definition of matching coefficient is measures similarity by counting the number of attributes that match between two objects. So the main next one is the main formula for this is d of p comma q equal to number of matches divided by total number of attributes. The main application used is data mining and a clustering task where attributes are categorical. Next one is ordinal attribute. Ordinal attribute having a meaningful order, but the intervals between values are not necessarily equal. Ordinal distance measures the distance based on the ordinal ranking. Formula: d of p comma q equal to r of p minus r of q, where r of p and r of q represent the rank of the values p comma q respectively. Applications used in scenarios where the order matters but the exact difference between levels are not uniform. Next one is Spearman rank correlation. It measures the correlation between the ranking of two variables. Next one is binary attribute. Binary attribute have two possible values, often representing a presence or absence or true or false condition. Next one is in that Jaccard distance measures dissimilarity between two binary attributes based on the proportion of mismatches. Applications is used in comparing sets or binary vector. Effective for attributes that are binary or categorical with a small number of categories. Dice coefficient, similar to the Jaccard distance, but places more emphasis on matches. Textual attributes consist of text or unstructured data. And next in that, cosine similarity, which measures the cosine of the angle of two vectors in a multidimensional space. Thank you.